Okay, good morning, everybody. Welcome back. Hopefully, you had a good vacation and you're super excited to dive right back into the math stuff, which is what we're going to do. We have a couple weeks left, then we have finals. When we went into vacation, we just wrapped up with using complex, sophisticated tools to approximate areas under the curve using left and right endpoint approximations. We talked about how if we wanted to be really cruel, we could drive that number of rectangles that you're using up really high and make you do a bunch of tedious calculations. Would for that be, if we had time, I would make you do that, but we don't have time, so we had to rush kind of through it. And I think the final point was that as you get more and more rectangles, the left and right endpoint approximations become the same thing as n goes to infinity. If that's confusing, and that's fine if it is, go back and watch those videos because they are going to be helpful. They are conceptual, and you should review them. Today we're talking about polynomials, and we're talking about polynomial graphs, and you can see a couple different graphs flashing before you, and just a couple terms that are going to be important that you're going to see throughout that I thought would be helpful to define before you go through this activity is number one is called the degree. Okay, so the degree of the polynomial. Polynomials can be written in a couple different ways. This way that you're seeing all these is called standard form, where they're all written as terms. And the alternative is factored form. So an example of factored form looks like this one right here. See how the polynomial is written as a set of factors. When a polynomial is written in a set of terms, it's very easy to look at and uncover, discover, identify what the degree is. So the degree is going to be this exponent it's the highest exponent in there. If it's written in standard form, it's written in descending order, so it's going to be the leftmost term. So in this case, the degree is 3. In this case, it's 2. In this case, it's 4. Okay, notice that there's a pattern, a relationship between the graph and the degree. What the degree is telling you is how many times the function can have these humps, which we call local minimums and local maximums. When the degree is 4, it's got 3 humps. When the degree is 3, it has 2 humps. And when the degree is 2, it only has 1 hump.